All right, folks. This is a special subject under synthetic division, and what I'm going to do is I'm going to explain the role of zeros in synthetic division. So what we're going to do is we're going to divide this polynomial right here by x minus 3, and what I'm going to show you is what you may notice is interesting here is I want you to notice that it's an x to the fourth polynomial, right? But notice there is no x to the third term. There also is no x to the first power term, right? So one of the biggest mistakes that a lot of people make when they do synthetic division and they see something like this, I'm going to show you what they do, but don't do this, okay? I'm going to show you what they do, but don't you do this. Watch this. We know we're going to do a half box, and we know we're going to put a positive 3 in the half box. Now when we look at our coefficients, we have a 1, a negative 7, and a negative 10. So 1, negative 7, negative 10. This is incorrect. All right? You actually have missed a couple coefficients. See, technically, this polynomial up here is actually x to the fourth plus 0x to the third minus 7x squared plus 0x minus 10. See, synthetic division isn't very forgiving. It's a program. Synthetic division is basically like a computer program sort of thing, and you have to fill in for every power of x. Now, technically, there's a 0x to the fifth, a 0x to the sixth, but the thing is, because there's nothing but zeros in that direction, it doesn't affect any of the, that's actually one of the reasons why we wind up putting a 0 under the first number, is because that's what's being carried up previously. It's just a whole bunch of zeros being carried up. 0 times 3 is 0. 0 times 3 is 0. It gets carried up. That's why there's a 0 here, okay? And 1 plus 0 is 1, all right? But, so synthetic division requires that you have all of the powers filled in. And when a power is not represented in a polynomial, you have to fill in with a 0. So what you would actually have to write here is 1. There's no x cubed term, so we have to put in a 0. Then a negative 7 for x squared. There's no x term, so we have to fill in with a 0. Then minus 10. See? 1, 0, negative 7, 0, negative 10. Okay? And what you'll see here is this, is because this is the x to the fourth column, this is the x to the third column, this is the x to the second column, this is the x column, and this is the constant. Right? So now we have to fill in with these zeros. Now, that doesn't mean that when we get our answer, there may not be any zeros in the bottom here. And that's another reason why we have to have those columns open, is because down here, those might not wind up being zeros, and therefore we need to have a space for those numbers. So the rule is, here's the rule, just to boil it down after all that talking I just did. The rule is any power you skip over in the dividend, any power you skip over, you have to fill in that space with a 0. Okay? Now we can do synthetic division. Put a 0 here. 1 plus 0 is 1. 1 times 3 is 3. 3 plus 0 is 3. 3 times 3 is 9. Minus 7 is 2. Times 3 is 6. Plus 0 is 6. Times 3 is 18. Minus 10 is 8. And that's our remainder. And so now we just go back to our original problem. What was the highest power up here? 4. So this is going to be to the third power, 1 power less. So this is 1x to the third power, or just x to the third power. Go down in powers now. So now we have plus 3x squared, plus 2x, plus 6. We have a remainder of 8, so it's plus 8 over x minus 3. There we go. And this is that's our final answer. Okay? All right. Now I want you to try one. Pause the video. Try this one out. All right. I hope you had a chance to try this. I hope you filled in your zeros where you had to. All right. So let's check it out. We're going to draw our half box. This is x plus 4, so I'm going to put a minus 4 there in the half box. Now, I'm going to put a 2 here. That's x to the 4th. Now, we skipped over x to the 3rd and x to the 2nd. So we got to put zeros in. There's 0x to the 2nd, or x to the 3rd, then 0x to the 2nd, and now x to the 1st has 125. Lastly, we have a constant of minus 10. We're going to draw our horizontal line. Now we're going to execute. Put a 0 under the first number. 2 plus 0 is 2, times negative 4 is negative 8. Negative 8 plus 0 is negative 8. Negative 8 times negative 4 is positive 32, plus 0 is 32. 32 times negative 4 is negative 128. Negative 128. Plus 125 is negative 3. Negative 3 times negative 4 is positive 12. Minus 10 is 2. And that's our remainder. Okay? Now, the original question started out as x to the 4th. So this is going to be x to the 3rd. Yep. So this is going to be 2x to the 3rd minus 8x to the 2nd plus 32 x to the 1st, or just x, minus 3. And then we have a positive 2 remainder, so we're going to put plus 2 over x plus 4. And that is our answer. That's our quotient to dividing that rational expression. Okay? All right, let's just do, I'm going to do one more example, and then you're going to do one more example, and then we're going to call it quits. And then I'm pretty sure y'all are good at this by now. Synthetic division, I'm telling you, you're going to love this. My students always love synthetic division because it's very straightforward. As long as you remember your zeros and know how to write the remainder, and you also have to remember to reduce the power by 1 when you're writing your answer. Hey, Mr. Ryan, you didn't skip over any powers this time. Where's the zeros? You just be patient. I promise you, zeros are coming in this problem, okay? But they're not coming in the question. They're coming in the answer, okay? All right, so we're gonna do our half box. What are we going to put inside the half box? Positive 6. Then we've got a 1 in front of the x to the 4th. Then a negative 6 and a negative 5. Negative 5. Then we've got a 27 and an 18. Then I'm going to draw this line here, right? Then, how are we going to start this? Put a 0 under the first number, right? 1 plus 0 is 1. 1 times 6 is 6. 6 minus 6 is 0. Ah, there's a 0. Okay. All right, 0 times 6 is 0. Minus 5 is negative 5. Negative 5 times 6 is negative 30. Negative 30 plus 27 is negative 3. Negative 3 times 6 is negative 18. Negative 18 plus 18 is 0. And look, there's another 0 in the remainder. That means we're not going to write the remainder portion in the answer. So, this started off as an x to the 4th, right? And so that means this column is the x to the 3rd column. That makes this column the x to the 2nd. I mean, in the answer, the answers are 1 power less than the question. So in the answer, this will be the x to the 3rd, this will be the x to the 2nd, this will be the x, and this will be the constant. Okay? So we're going to have 1x to the 3rd, or just x to the 3rd. Now, for the x squared, we have 0x squared. And therefore, that's just 0, because 0 times anything is 0. So we're not even going to write 0x squared. We're going to skip x squared, and we're going to go straight to the minus 5x. Minus 5x, then the minus 3. There is no remainder, so we're not going to write anything else. And this is our final answer. And I want you to notice something. Because the remainder is 0, remember I said this, I think, in the last video? Because the remainder is 0, that means that x minus 6 must be a factor of this polynomial. We're going to get to that at a later time, but I want to keep saying it to you so you hear it a couple times before I teach you that particular lesson. Okay? All right, are you ready to do one yourself, your own example? All right, good. Let's go ahead, pause the video, give it a shot. All right, so I hope you felt very confident with this. It's very straightforward. We're going to put a half box, put a positive 2 in the half box. Then we're going to bring over a 5, a negative 10, and a negative 3. Negative 10, negative 3. We didn't have to skip anything, didn't have to fill any zeros in because we got fifth power, fourth power, third power, second power, first power constant. So no, don't have to fill anything in. All right. So let's. Then we got a 6, a 7, and a negative 10. A 6, a 7, and a negative 10. All righty. Now we're going to put a 0 under the first number, and we're going to execute. 5 plus 0 is 5. Times 2 is 10. 10 minus 10 is 0. 0 times 2 is 0. Plus negative 3 is negative 3. Negative 3 times 2 is negative 6. Plus 6 is 0. That's another 0 in the answer. 0 times 2 is 0. 0 plus 7 is 7. 7 times 2 is 14. Minus 10 is 4. That's our remainder. Now, the problem started out as x to the fifth. That means that the answer is going to be it's going to start off with x to the fourth, right? Then this is going to be x to the third. This is going to be x squared. This is going to be x, and this is going to be our constant. Okay? You do not have to write these in at the bottom. I'm writing them in as instruction to show you what I'm thinking while I'm doing the problem. Okay? But once you get to doing a lot of these, you won't need to be writing all this stuff down here. You can if you want to, but you don't have to. So this is 5x to the fourth. 0x to the third, so we're going to skip over that one. And we're going to go straight to minus 3x squared. Plus 0x, so we're going to skip over that one and go straight to the positive 7. So plus 7, that's not a very good plus sign. Let me write that again. Plus 7. Then plus 4, the remainder is 4, so plus 4 over x minus 2. There we go. And this is that's our quotient. Okay, that's our answer. All right, well, this should probably be enough for you. If you're not sure, you can ask me some questions, but I will be sure to give you plenty of practice to make sure that you're very good at synthetic division. It's very useful, this synthetic division. It's very useful in calculus. So if you're somebody who's eventually going to take calculus, you're going to want to keep this tool in your toolbox, and you're going to want it to be well used, well sharpened, and ready to go.